Okay, hello everybody. So today we are going to dive in to what the Pythagorean theorem is. This may be a new topic to some of y'all. However, if it is not, that's awesome. But we're going to dive in. We're going to learn about just some background knowledge, what the Pythagorean theorem looks like, how it's applied in the real world, and then we'll use some real problems and we'll solve them together. So here's some of our learning targets. First, we're going to define the Pythagorean theorem. Then second, we're going to define a right angle, as this will be important to our theorem. Step 3, we will then apply the Pythagorean theorem. And then number 4, we will identify real life applications to the Pythagorean theorem and why we need to know it. Okay, so introduction. The Pythagorean theorem states that in a right triangle, specifically a right triangle, the square of the hypotenuse is equal to the sum of the squares of the leg. So we can see that this is a right triangle, right? Because these two lines form a vertice, and at the vertice we have this figure, right? And it forms a small little square. This square represents a perfect right angle, or 90 degrees, right? And with the Pythagorean theorem, we must have a right angle in our triangle to be able to apply this. Otherwise, it does not work. It does not work for acute or obtuse angles, right? We must have a right angle. And then this right here, we see a squared plus b squared equals c squared, right? We're taking the a, the b, and the c from this right triangle to make this equation. And ultimately, this is the equation we will use for Pythagorean theorem. Okay, let's go through some history, just so we have a little background knowledge and just know a little bit about the Pythagorean theorem. The ancient Greek mathematician and philosopher Pythagoras is credited with discovering this relationship in the 6th century BCE due to the prominence of his religious mathematical school in Cranton, Italy. So now we know this man is the one who discovered it, created it, and just from his curiosity, right? That said, it was likely independently discovered in several different cultures. There is evidence of it in Egypt, Babylon, and China as far back as the 20th century of BCE, right? So this is a long time ago. We know that this has been here for a while. This isn't a new concept, and they've been using it for decades and generations. So it's just kind of cool that we know a little bit of the history about this. Okay, so we're going to use some visual proofs. As we know, we could just learn about the Pythagorean theorem and just learn a bunch of definitions, but I think it's really good to see what Pythagorean theorem really is as of like the models and visual things, right? We're going to construct this model, right? We will take paper, we're going to cut it up after this so we can visually look at it. But the Pythagorean theorem has been proved through hundreds of methods, and new proofs are still being discovered. Here is an example of a visual proof showing the squares of the side. Notice 9 plus 16 equals 25. So these, the 9 and the 16, right, the area of these two squares equals the area of this one big square. And we see our right angle, right? So these are the two side lengths. And this side length right here where the 25 area is, this we call the hypotenuse, right? And this would ultimately be the c in our equation. Okay, so now what I just said, we're going to understand a little more, right? So understanding right triangles. A right triangle is any triangle with one right angle. We know that. The two sides, so here's a leg and here's a leg, form the right angle and are called the legs. The side opposite of the right angle is called the hypotenuse. So we can see that in our visual, right? A right angle creates many special relationships between the sides and angles of the triangle and is the basis of the mathematical branch of trigonometry. We're not going to learn much about trig today, but this is all the foundation, right? We will all need to know this in our future math courses. All right, so using the Pythagorean theorem, when are we going to use it? How are we going to use it? What do we need it for, right? So in step 1, we're going to identify the two legs of the triangle and the hypotenuse. Note the length. A is a leg and B is a leg, correct? Because it forms this right angle. Number 2, determine which side you are trying to find. Do we have the values? What values do we have, right? Do we have A? Do we have B? Do we have C? And then 3, substitute your links into the Pythagorean theorem equation and solve for the missing value. So we're going to start plugging in. If we know A, we're going to plug in A. If we know C, we're going to plug in C. All right. Using the Pythagorean theorem, identify the two legs. Leg, leg, right? The legs will always be identified as A and B. The hypotenuse will always be a C, right? All right. Now we're given a real example. We're giving values in units. So we have 8 inches for leg A. We have 15 inches for length B, right? And so ultimately we're trying to find C, which is the hypotenuse. Okay, so now that we know A, we know B, we're trying to find C. So let's substitute into our given equation. So we replace A with 8, B with 15, and leave C as our variable. We square 8 to get 64. We square 15 to get 225. This will equal C squared. So now that we have added these two values together to get 289, we are going to square both sides, square root both sides to get rid of this square 2, right? So now we're going to get C equals 17 because we took the square root of this number. All right, and then here's just some real life applications. So 1, buildings and architecture. A lot of engineers and architectures and just all kinds of things in our world, in our cities and our towns need the Pythagorean theorem. We also use it in navigations and GPS and games and sports, surprisingly. So ultimately, here's our summary before we work on our assignment for the day in the class. We know that the Pythagorean theorem describes the relationship between the sides of a right angle. It can be used to find the missing side of a right angle, which can be applied to solve many real-life problems. Understanding the Pythagorean theorem is a great foundation for learning trigonometry, the distance formula, and so much more. What other examples can you think of for using the Pythagorean theorem in your life? All right, guys, after we have discussed this, we can move on to our worksheet.